Okay, let's see a little small demo about how to start a project with the Ghidra. So first we need to create new project. It's quite simple. We don't want any shared projects because that's kind of fuck up. And we need to choose the working directory. I have created something called sample directory. And project name. Let's just write a demo. And now we have a new project, and first we need to import a binary, and there's an import file. And because this all started with this impossible mission, so let's go into my project directory, and it's this memdump file, and it's 64K, so let's take this. And now we are importing, and then it will ask about the format. It's a raw binary. Language is 6510 if we want those illegals to go with. And then we have to choose the options and write to the block name that it's RAM. And it doesn't mean a lot if you leave this checked. It just wants to name the stack and the 0 page things. And the length is 64Ks. I think we should be okay. Just press OK and OK. And there's some jibba jabba about the process. Minimum address 0 and last byte FFFF. Okay, and then we open the binary and we just double click it. There, and here we have the binary open, and now we need to add layers to it. So there's a menu, file menu, add to program, and we want to import an IO layer, the ROMs. Yes, it has. So we choose IO, and it's a raw binary, and on the options we click overlay and call the block IO and give the base address where it is in the RAM. So 4K in the D000. Can really leave this out and just hit OK. And it complains about some undefined byte, but I guess we don't have to care about that. And then we need to add another layer. So add to the program, and then we choose kernel ROM, add to program, and options overlay, and call it kernel, and the base address. Oh. And just OK and OK. And now we have a project which has RAM, IO and kernel layers. And now if we click here on the left, the IO, the program goes at the IO layer and kernel layer and the RAM. And it's not really important yet. But now if we want to import symbols, so we go to window, and then it's script manager, and again it opened on the wrong window. I have this import symbol script, and I have assigned key F12 to there, so which I usually use. And we load the IO symbols, and somewhere here is console output, and we can see here that it created the labels on the IO layer. And then I want this kernel layer information or the symbol, so I just hit F12 and then load kernel. And yes, here we have the symbols loaded. I could load the RAM layer symbols too, but it's not very useful on this project to know the pointers and such stuff. And now we have the 3 layers, we have the symbols for them, and now we can see about this binary, how to go to work with it. And I have already find out that the program starts as 3855, so here I press G button and then tell the address, and we jump there. And here we can see at the first hex is this A noun, which is LDA, and now if we want to, it was D for disassemble, yes. And now the Ghidra starts to work and goes through the whole program. On the right you can see memory locations, which it has found, etc. And here we can see what the program does. And at first we put 60 in the DD03, and now this is referring to RAM, but we know that it's meaning the IO, so we press R here, R key. Of course it opens a different window, or it's right click. Is it here? Nice demo. There's a whole new menu item, references, and with the R key we can edit references. And here we can see the destination. We just double click it and choose that it's pointing to IO layer, and hit update. And here it's now pointing to the IO layer. And this is important because we have, if we jump to the memory where the IO is, we can see that there's lots of writes, of course, to the IO registers, but these are pointing to RAM. But the RAM is used under the EO, so we need to fix all these references to the RAM. We need to fix these references to the IO level. Of course, not that, because it's the next line. So we press R, click, and IO. And I don't have an idea how we could make this automatically. I guess it would be possible, but then again, we don't know if the program is pointing to the RAM layer or in the IO layer. So it's case by case. You need to go through this if you want to be sure that it goes right. And if we go to the program start again, and here what it all starts, we could use window and function graphs, and oops, wrong window. And this is now the function graph for the whole program, and it's not very useful because you usually use this on the subroutines and such. But when you click here, the code flow, it goes into the program listing tree to the same place. And branching and such, you can see the graph, how the program flow is going. So clicking this here will show you the listing where it is actually there. And I guess the main game starts somewhere here, because there's lots of branching and they all go somewhere. But as I said, this is not very useful to see it on this level. Usually you grab some subroutine and start to look at this, what happens there. And then something you can see, if we find here some lots of code, you need code. And there's fun, and the fun refers to function. And here we can see references, and these are the addresses where this is called. And we can also choose a window and check symbol references. Okay, this is not the window I was talking about. God, back button. And here you could see that this function is called from these addresses, and if you click this, you can go to the code location where this is called, and this can be very useful. And of course, this is the normal Ghidra stuff. I didn't do anything about this, but this byte reading routine I've been toying with, and we can check here the tool key and just see that we want to see 16 bytes a line, and we want to see the memory presented in hex and C64 char set, and this means the screen code and then Petsky also unshifted and unshifted. And now we can see through the memory how it looks like in the screen code or the Petsky code. And this can be useful if you are trying to find the strings or other patterns, you know. I'm really good at looking patterns, so I usually see the music and stuff, music data from the patterns. But I understand it's my click in the head, so you use your own methods. But that's why I started to toy with this Ghidra and make these Commodore screen codes. And of course, if we want to see it in ASCII, it's not very informative because there's not anything in ASCII in this game. Also, actually, all the strings are not in Petsky or in screen code. They use different codes, so you can't really see them on this game. It would be possible to make here to see the memory in maybe charset data or sprite data. But I haven't been thinking about that because the retro debugger is so useful. I don't really need this functionality in Ghidra. And one more useful thing is this listing tree. It doesn't look like this in the default settings. So there's the button, I don't know how to call it. It looks quite messy. But here you can choose what kind of information you want to see on the screen, and you can change the spacing and stuff the way you like to see it. And it's broken into some tabs here, different things, and you can disable something by using right click. So if we don't want to see the address, we just disable it or enable the fields. And you really need to spend time here a lot to make the working comfortable. Also on the left you can see those program flow arrows, such. They can be useful and more or less useful. It depends. And if you hit the button again, it hides this. And you can tune this out with if I only could remember, it's been years when I was customizing this to my liking, so I don't really remember the name of the places. It's quite annoying. Tool options, of course, edit. And here you can change the fonts and colors and such. But first thing, is not here, so we'll close this program listing. Yes, we want to save. And from this main window, there's an edit and theme and switch. And there's this flat dark theme I use for the basis. And this is my own version of it. And if we just go to the configure and choose fonts tab, here we can write the byte weaver. You can see I have changed the byte weaver font to PetMe 64 font. And that's the font currently which can show the screen codes correctly. You should at least change that. But I also like to see the code in Commodore characters, because all my life I have been looking the code using that font. So font listing base is the same PetMe. And there are so many options that you can really burn yourself out if you want to customize everything. So I really suggest that you go slowly here and save the themes and maybe different versions and different names, because you get lost here. And this is typical open source. Of course there are documentation, but Piotr's getting to read through it. It's partly outdated and such, so you have been warned.